I've still got up on the board here the initial value problem that we did last time. We did two things. We found the Maclaurin series, or what we hope is the Maclaurin series. We guessed what we think it is, okay? And then we found the fourth Maclaurin polynomial, which is just the fourth partial sum of that Maclaurin series, where we stop at the term of degree 4, okay? All right, I want to point out one thing that's very, very important when we do this, and that's that P4 of t is not a solution to this differential equation. We are hoping that the entire Maclaurin series is a solution. Okay. This is what we would use to get a decimal approximation of values on the curve for particular values of t. This is approximating a solution, but we are not claiming it is a solution, and in fact it's not. Okay. We can see that quite clearly because if I look at the derivative of P4 of t, that would just be, let's see, 0 plus 1 plus 2t squared plus t cubed. Notice that's a third degree polynomial. If I look at the right-hand side of this differential equation with P4 plugged in, t squared times P4 of t plus 1, I'm going to write the 1 first. That would give me 1. Plus now I've got to multiply each of these terms by t squared. So I'm going to get 2t squared plus t cubed plus 2/3 t to the 5th plus 1/4 t to the 6th. That is a 6th degree polynomial. There is absolutely no way that this third degree polynomial is equal to that 6th degree polynomial. Okay? And it would be wrong to say that they are. So, when we did this problem, we were actually asked to find the entire Maclaurin series, describing things recursively, and then as part 2 to find this. In some of the homework, you're just going to be asked to find the series up to degree 4, or up to degree 6, or equivalently to find the 4th or the 6th Maclaurin polynomial. When you do that, you need to recognize you are still working with the series and just stopping at a certain point. So don't write out your differential equation using polynomials and saying this polynomial equals that polynomial, because that's almost guaranteed to be a lie. Saying something like this third degree polynomial equals that 6th degree polynomial. You want to, even if you know you're going to be stopping at a certain point, you want to always acknowledge that you're working with the entire series. So there's no way this could equal this. But if I had, if I were working with the series and I wrote 1 plus 2t squared plus t cubed plus ... that could absolutely equal this if those extra terms included my 2/3 t to the 5th and 1/4 t to the 6th. So make sure that in your work, even if your answer is going to be a polynomial, you acknowledge that you're working with the series, either by writing things in summation notation or by just writing things out term by term, but acknowledging that there are additional terms. Okay.